All right, hey everyone. We're Team LeBroncos, and we built PocketBuddy, an offline AI tutor for students who can't count on having Wi-Fi, because learning shouldn't stop where the internet does. My name is Leo.
My name is Kelsey.
My name is Nick.
My name is Michael. My name is Greg.
What's
All right, here's the problem. Every AI tool out there, ChatGPT, Gemini, Copilot, they all assume you have stable internet, an account, and a modern device. But for many students around the world, that's just not the reality. No internet often means no help, login requirements create barriers, and unreliable power means inconsistent access. The real gap isn't about inadequate technology, it's about accessibility to it.
That's why we built PocketBuddy. It's an offline-first AI learning companion that runs entirely on-device. No login, no cloud, no internet needed. It's designed specifically for students in low connectivity environments who desperately need academic support they can always rely on. Here's what it looks like.
Here.
We designed and 3D printed a custom enclosure that houses a Raspberry Pi 5 and an LCD screen with a wireless keyboard on the side. This isn't a repurposed phone or tablet. It's a device built specifically for offline tutoring. It's compact enough to toss into a backpack, and the keyboard-first design supports real writing, problem solving, and even latex math, as we'll show in the demo.
So how does it actually work from the student's perspective? It's simple. They type in a question and the on-device AI responds with a refined instructor-style response. There's no loading sprinter waiting on a server. It just works even with zero connectivity. So to prove that, we're going to do a live demo right now with no Wi-Fi, only local inference, and using a real student workflow. All right, sweet. So we have the device right here. A little big to fit in your pocket, but in future iterations, there's a lot of hardware changes we can make to make it smaller and more fitable. So as we saw, you went ahead, put in a question, and you press enter. It does take some time to load, but on the software side, that's something we could kind of make more user-friendly. So I'm going to press enter again and press, we have a clear command here. So I'm going to go ask a very simple educational questions. I just finished calculus, so let's try and ask a calc question. So what is the integral of x squared? Made a little typo, so I'm just going to quickly edit that real quick. The terminal is really simple. It's almost like just like a really simple text editor, and we just want the user to be able to put questions inside of it. So go ahead, press enter, and it's going to go load and fetch for an answer. Like I said, we have a local LLM model inside, so no API calls to any internet base. You could access it anywhere. Big intention of not just students, but possibly even extensions to places where technology is not as advanced. So people who aren't as fortunate as the people who live in the US or other more modern countries can have the powers of LLM right in the palm of their hands. So we could see here that we have an answer from the LLM telling us that the answer to the question of the integral x. The integral represents area under curve, yada yada. So typical LLM response you would expect. So it does have its limitations on how we would use an LLM as well. Maybe sometimes we ask a question and it doesn't do too well, but overall the idea is that we have the power of this chatbot LLM at our fingertips when we need it. So if you want, while we go ahead and do the rest of the presentation, we have two keyboards here. One is more handheld use, but also we use a regular keyboard as well if anyone wants to answer and kind of use it as we go. So like Brett, we'll have that right here for you to use. If you want to change the screen, we have an input and an output mode. Just go ahead and press enter, and you'll go back to the question, and then you can press Control L to clear your output, and you can play around with that.
All right. So one engineering challenge. One engineering challenge with running an AI locally is heat. So to mitigate this, we installed a dedicated cooling fan that prevents thermal throttling and keeps the Pi running at stable temperatures, even during long study sessions for students. So every choice here was intentional, portable enough to go from school to home, fully offline, keyboard first, so students can do real problem solving, and a math-friendly interface built in for STEM work. So under the hood, we use a lightweight open source language model that's preloaded on the device. The pipeline is straightforward. The model lives locally, inference runs locally, and the student gets an instant response. No cloud latency, no network dependency, just fast, transparent, open source AI.
Moving forward, we're focused on optimizing inference speed, improving battery integration, and refining the display and keyboard experience to make PocketBuddy even more practical for everyday student use. PocketBuddy is a reliable offline AI learning support built for students who need it most. Thank you.